is an atom discussed. Modern day symbols discussed. Yes. Atomic mass is left. And then we discussed how do atoms exist. Yes, bache? Molecule has been discussed. Atomicity was discussed. Iron was discussed. Was iron discussed, Umaima?
Yes.
Was iron discussed?
Yes. No, I
Fine.
don't think.
Iron was not discussed. No worries. We'll start with the iron. We'll start with iron, then we'll come to the atomic mass. Fine. What is an ion, bacho? What is an ion? Any idea regarding ion?
Charged particle.
Excellent. A charged species or particle, right? So if I say there's one atom, this is sodium atom, okay? This could also be charged. How? This is an atom initially. If it loses one electron, it will gain the charge. If it loses one electron, it will gain the charge of +1. It will gain the charge of +1. It has become a charged species, therefore it becomes an anion. Sorry, it becomes an ion, okay? It becomes an ion. Now second, let's say another atom I have, that is oxygen. Here it's an atom, okay? It gains 2 electrons. It will gain a charge of -2. We'll discuss why +1 and -2 are there. We'll discuss that in the next chapter. But as of now, just know that this oxygen atom will have a charge of -2. Therefore, it has become a charged species. Yes. Therefore, it will again be an ion. Now, what are the two types of the ion? See, ion could be called as a cation and anion. Cation is the positive anion. Cation is the positive ion, and anion is the negative ion. Cation is the positive ion and anion is the negative ion. Example, sodium plus, potassium plus, calcium 2 plus, magnesium 2 plus, aluminium plus 3. Okay,
Good
these are all
evening, ma'am.
examples. Good evening, Faraz.
Sorry for joining late.
No, that's fine. We are starting from some of the topics of the third chapter. So you can also join in because although we have started the third chapter for you yesterday, but you can join in these topics, okay? We are discussing how do atoms exist. Now, negative anion, okay? Can you give me an example of a negative ion, Muhammad?
Onions?
Yep. I'm asking for any example, bache. What is this? Oxygen gains a charge of -2. Therefore, see,
Ma'am,
is
chlorine.
it correct?
Yes.
Is this symbol correct? Whatever I've written here. O2 - 2 is this correct for oxide?
Yes.
Chloride, ma'am.
Chloride. Excellent. Chloride. Is this correct? O2 - 2. O - 2 is correct. Oxide. This is oxide. This is oxide. This is chloride. This is iodide. Keep on writing the names. Iodide, chloride. Okay. Fluoride. Okay. Fine. So these are atoms with the charge. Therefore, they are single atoms with the charge. Okay. Now there are also some compounds or polyatomic ions. Some compounds with charges. Compounds with charges or polyatomic ions. Okay. Now we have already discussed about molecules, compounds, elements in the last class. So if there's any problem, please tell me that because otherwise we have discussed all of this. Now see, if I say this is sulfate, okay, these are there are many atoms in this compound and this has a charge of -2. Therefore, it's a polyatomic ion. And the name of this is sulfate ion. Sulfate ion, okay. What is this? Nitrate. NO3 -1. Definitely many atoms here, therefore it's a polyatomic ion and the name of this is nitrate ion. Nitrate ion, okay. Carbonate, CO3 -2. Okay. Ammonium, NH4 +1. Ammonium ion, okay. Ramesh, Faraz, Umaima, and Abdullah's camera is on. Please turn on the cameras.
Ma'am, the meeting is not in the focus.
So
So my mom doesn't allow me to like on the camera.
that means you turn the camera on, bache. Fine. Any problem here in the iron part? Ali, you were not present in the last classes when we were discussing this. Any problem here?
No, ma'am.
Compounds composed of metals and non-metals containing charge species, okay? The charge species are known as ion. The same part. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. Example, sulfate. This total has a charge of -2 on itself, okay? Net charge, okay? Group of atoms having a net charge on them. Anion can be negatively or positively charged. Anion and cation, okay? Anion and cation. What is the next part? A group of atoms carrying a charge is known as a polyatomic ion. Okay, that's it. Any example, any problem here? Just know one thing. Whenever, Faraz, but I'm muting you because I think echo. Whenever it is a non-metal, which is an atom, okay, non-metallic atom, whenever this will gain a charge, whenever this will gain a charge, the name will change. Example, chlorine is a non-metal, okay? And if it changes to Cl minus, we will not call it as chlorine, rather we will call it as chloride, okay? But if we have sodium atom, which is a metal, okay, if it gains a charge of +1, this will still be called as sodium. Is it okay? Therefore, when non-metals, the atoms of non-metals, they gain the charge, they change into ions, the name changes. Oxide, chloride, bromide, fluoride, iodide, sulfide, nitrite, okay? The name is changing because it's a non-metal which is gaining the charge, which is changing into an ion. Is it okay?
Explain again.
Yes.
Explain again. Okay. My point is, let's talk about the single atoms, okay? Single atom. So either the atom could be a metal or a non-metal, right? Or a non-metal. So this is, if this is an oxygen sodium atom, if it gains a charge of +1, okay, it has become into iron, okay? It has become into iron. This is the chlorine atom, it gains a charge of -1, it has also become into iron. This sodium ion will be called as sodium ion. Okay, this sodium ion will be called as a sodium ion because this is a metal, okay? The chlorine ion will not be called as chlorine ion, but rather chloride. Chloride. Why? Because it's a non-metal. Okay. Whenever the atoms of non-metals, they are gaining the charges, be mindful of this. Whenever the atoms of non-metals, they are gaining the charges, the name will slightly change when they are in the ionic form. Oxide. O2 minus is oxide. It's not oxygen. Okay. O2 minus is oxide. Oxygen is a non-metal already discussed in the second chapter. When it gains a charge, therefore the name will change to oxide. It's an oxide ion, not an oxygen ion, okay? But if I say magnesium +2, this will still remain magnesium ion. Is it clear now? Is it
Yes,
clear?
ma'am.
Fine. Now, example which has been discussed in the NCERT, whenever we have a positive ion and whenever we have a negative ion, both of them, the example here, they will bond to each other. Positive and the negative ions will bond to each other, okay? Therefore, NaCl, when we see the compound that is NaCl, okay, is nothing but a combination of a positive ion and a negative ion, namely sodium ion and chloride ion respectively, okay? Okay, if I say we have magnesium sulfate, tell me the ions here, quickly. Magnesium sulfate. Yes, Acho. I've
Can
discussed
you,
these ions right now. Can you tell
can
me
you
the ions
repeat?
present in this compound? Yes, yes, Vache. Can you tell
Magnesium
me
is positive.
+2? Yes,
Yeah.
magnesium is +2. Fine. What's the other ion here? That is the anion.
Sulfur.
Sulfate, but sulfate. SO4 together has a net charge. Yes. See,
Yes, ma'am. Yes.
this has a net charge of -2, and this is called as the sulfate ion. Okay. Net charge. This NO3 has a net charge over itself. This carbonate has a net charge of -2. Okay. This ammonium NH4 has a net charge of +1 there. Okay. That is the point. That is what we mean by the polyatomic ion. Any confusion here? Because next we are moving on to a very important topic, that is atomic mass. Yes. Umaima, Ramiz, Abdullah, Ali, and Faraz. Any problem till here? Should we start with this topic?
No, ma'am. We,
Okay.
Yes, ma'am.
yes, ma'am. We can start this topic.
Yes, ma'am.
I've got what? One laptop, okay? How will I weigh this? I will use a weighing machine, okay? And I'll get the weight in somewhat very like 1 or 2 kgs, right? I will get the weight in kgs. What is kg here? What is kg here?
A unit of mass.
A unit of mass, right? I'm using this as a unit of mass. Okay. If I have some smaller mass, okay, I think I will use the unit of grams, right?
Yes, ma'am.
Fine. I will use the unit of grams. Can you give me any example of a mass which we take in grams? Any example?
Sugar.
Sugar. Fine. Let's say I'm saying 50 grams of sugar. Let's say I'm saying 50 grams of sugar. It's not that much, right? The quantity is very less. Okay.
Yes.
Let's say I'm measuring one small pebble, one very small pebble. Okay. It will be a very few grams, right? But what is this kg in grams? These are the units of mass. Okay. These are the units of mass. Now, what do we mean here by the units of mass? What do we mean here? We would have actually said that, let's say some amount of the matter is equal to 1 kg, right? And let's say the laptop weighs 2 kgs, okay? Then the mass of my laptop would be as twice as the mass of this matter, right? That is why I'm saying 2 kg. I would have assumed some mass to be equal to 1 kg, right? I would have assumed some mass to be equal to that 1 kg. And if I'm weighing anything in terms of kg, that will be 2 times, 3 times, 4 times the mass of that matter, right? Are you getting this?
No, can you repeat?
Yes, I can surely repeat. Fine. Let's say I have this square box, okay? Let's say I have this square box. And the mass of this square box was x. The mass of this square box was x, okay? Now, whatever the mass of this square box was, I don't have any unit as of now, okay? I don't have any unit as of now. Whatever the mass of this square box was, I said that I will consider that as 1 kg. I will consider that as 1 kg. Clear till here? Clear till here? All of you, please respond.
Yes, ma'am.
Yes, ma'am.
Now I say, I want to weigh my laptop. I want to weigh my laptop, okay? Now, when I weighed my laptop, okay, it was coming as 2x. It was coming as 2x, okay? Therefore, I'm saying it is 2 kgs, yes? Therefore, if I'm saying it is 2 kgs, what do I mean by if I'm saying the laptop weighs 2 kgs? The mass of my laptop is twice the mass of that square, right? Because I have taken the mass of that square as 1 kg. Are you getting that?
Yeah.
Yes, ma'am.
Ali, yes. If I say there's anything, let's say there's anything that weighs 4 kg, that weighs 4 kg. What do we mean by 4 kg here? It simply means whatever that matter is, the mass of that matter would be 4 times of this square box, right? That is why we are getting 4 kgs. 4 times of that, whatever we have considered as the unit here. All of you agree with this?
Yes, ma'am.
Yes, ma'am.
Basically, what are we saying a unit is? We are saying a unit is nothing but a standard point according to which we are measuring our masses. A standard point, a reference point according to which we are measuring the mass of other bodies. Yes, other matters. All of you agree with this? So the importance of unit has been cleared. Abdullah, Ramiz, Umaima, Faraz, and Ali. Yes or no?
Yes, ma'am.
Yes, ma'am.
Right. Now, when we come to the mass of the atomic mass, can we measure this in kilograms? Can we measure this in kilograms? Certainly not. We can't even see the atom, leave alone measuring it in kilograms. We can't even measure it in grams. We can't even measure it in milligrams, okay? That value is also very big. Therefore, we needed any unit. We needed any unit in which the mass of the atom could be measured. In which the mass of the atom could be measured. All of you agree with this. We needed any unit in which the mass of the atom could be measured. Now, how do we get that unit? Let's see. See, there's an atom. There's an atom which is carbon-12 atom. Please note the name of this. This is carbon-12 atom. Okay. This is carbon-12 atom. Clear? We still don't know the mass of this. We still don't know the mass of this. Okay. We just don't know the mass of this. Now, what happened? We took the mass of this. Let's say it came out to be X. Okay. Let's say the mass of this one atom, one very small atom, came out to be X. Okay. It's still no units. I'm still not using any unit here. Okay. Now see what happens. I divide this into 12 parts. How many parts?
12 parts.
Okay, just please don't go on my drawing. Just assume that there are 12 parts. Okay. Equally divided 12 parts, fine. Equally divided 12 parts. So simple mathematics, I think, will tell you that the mass of each part will be X divided by 12, right? X divided by 12.
Yes, ma'am.
Is Ali even present in the class? Yes. So the mass of each equal unit here will be, by simple mathematics, we'll get as X by 12, right? X by 12. Now let's say I just take this part, right? This is what? X by 12. The mass of this one unit is what? X by 12, right?
Yes, the mass of 1 unit is X by 12.
Fine. All of you agree with this? Ramesh, Umayma, Bacho, respond.
Yes.
Yes, ma'am.
Right?
Yes,
And
ma'am.
now I take this as my standard point. I take this as my standard point. That is the reference point. Okay. I take this as my reference point. Now let's say here, please understand this point. I have an oxygen atom. What? An oxygen atom. Okay. An oxygen atom. Okay. Now when I weighed this oxygen atom, okay, this came out to be 8 times this. This came out to be 8 times of this. Can I say 8 units? Now can I say 8 units? Why? Because I'm considering this as the standard point, right? Yes or no?
Yes, ma'am.
Yeah.
8 times of what? 8 times the
Ma'am, what is
mass
the
of...
standard point? What is the standard point? I don't
Okay, you
understand.
forgot that. No worries, fine. I took this carbon-12 atom. I took this carbon-12 atom, right?
Yes.
The mass of this carbon-12 atom was, let's suppose, X, okay? Let's suppose X, okay?
Yes.
Out of that one, out of those 12 parts, I took one part, okay? I took one part like this, okay? I took one part. The mass of this one part is what? X by 12. The mass of this one part is what?
X by 12.
X by 12, okay? This one unit, this one part out of those 12 parts has been used as the standard point, okay? Has been used as the standard point, clear? And when I weigh the mass of the oxygen atom in respect to this, in relation to this, it came out to be 8 times the mass of this one part. It came out to be 8 times the mass of this one part. Does this make any sense? Yes, it makes any sense. How? Let's see. How? Let's see. Let's say we have a weighing machine, weighing balance, okay, something like this. Please don't go on my drawing, okay? I took this one part here, okay? I took this one part here. Out of the 12 parts that we had, I took this one part here. And I took oxygen atom here, okay? And the mass of this one oxygen atom came out to be 8 times of this. Does this make any sense? All of you?
Yeah.
Yes? This is simple
Yes,
weighing,
ma'am.
right? Therefore, I say the mass of the oxygen atom is 8 units. 8 units. Is it clear? This is just the introduction here. Bacho, let me just tell you one thing. If none of you is opening the camera, I cannot continue the class like this because it seems like I'm talking to myself and there's no one in the class. Either my energy will go down or I will just explain it like this because as if I'm explaining to myself. That's it.
Ma'am, my camera isn't working.
Ali, are you there in the class?
It's ma'am. I was just like plugging the charger.
Okay. Fine. Starting from the next point. So this is some introduction regarding what do we need for the atomic mass. We needed a unit for the atomic mass. What did we need? We needed a unit for the atomic mass, okay? And in respect to that mass, whatever we have taken as the standard point, okay? In respect to that mass, in relation to that mass, we were measuring the masses of all other atoms. in relation to that mass, whatever we have taken as the standard point as the reference point, we were measuring the masses of all other atoms. Is this simple concept clear?
Yeah.
Is this simple concept clear? Therefore,
Yes, ma'am.
therefore, it is called as relative atomic mass. It is called as relative atomic mass. Yes or no? Therefore, it is called as relative atomic mass because we are measuring the mass of the atom in relation to some other mass, whatever we have specified there. Fine. And let's see how. Quickly come on to the NCRT. First, wait. The standard, whatever we are using as of now, let's see what is it. But what atom is this? Carbon 12 atom. Carbon 12 atom, okay? And we have taken one part out of the 12 parts of this carbon 12 atom, right? So therefore, 1/12, the mass of carbon 12 atom, okay? What is this? This is nothing but the unit here, right? This is nothing but the unit here. This is nothing but the unit here, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. And the unit of the atomic mass is taken as atomic mass unit AMU, and now it is called as U, that is unified mass. Unified mass, okay? So now whatever we use now, if I'm saying the mass of oxygen is 16 times, sorry, but that was not 8 times, rather 16 times, okay? Sorry for that. So if I'm saying the mass of the oxygen atom is 16 times or 16 units, what do I mean? What do I mean? 16 units is referring to what? The mass of the oxygen atom is 16 times the 1/12 the mass of carbon 12 atom, right? The 1/12 the mass of carbon 12 atom, right?
Yeah.
Yes, ma'am.
Is it clear? Umaima Bache, is it clear to you?
Yes, ma'am.
Abdullah, tell me yes or no? Very honestly. Faraz Bacho, is it clear?
Yes, ma'am.
Fine, excellent. Ramesh, is it clear to you, Bache?
Yeah.
Fine. So coming on to the NCRT now. Please open up your NCRT, is very important. See. Suppose we define the atomic mass unit. So basically, I have already discussed as to what is the need and the importance of a unit here, okay? First, we need to have a unit and then only we can measure the mass of that, right? First, we need to have a unit and then only we can measure the mass. I've already discussed that, okay? We define the atomic mass unit, earlier abbreviated as AMU, but now it is written as U, okay? That is unified mass. Earlier, we said the atomic mass is taken in the units of AMU, that is atomic mass units. But now we say that the atomic mass is taken in the units of U, that means unified mass. Is this point clear?
Yes,
Yes,
Yeah.
ma'am.
Fine. As equal to the mass of one carbon atom, okay? This is wrong, by the way. You should know this, okay? Assign carbon an atomic mass of 1 U. If I'm saying my 1 unit of atomic mass is equal to the mass of carbon atom, the mass of carbon atom, then definitely the mass of the carbon atom should be 1, right? Should be 1. If I'm taking that as 1 unit, it should be 1. But that is not the case, okay? That is not the case. While searching for various atomic mass units, scientists initially took 1/16 the mass of an atom of the naturally occurring oxygen as the unit. Let's say whatever the mass of the naturally occurring oxygen was, they said the 1/16th of that, okay, would be taken as the reference point, would be taken as the reference point or the unit, okay, would be taken as the reference point or the unit. And why did they think so? Why? Because oxygen reacted with a large number of elements and formed compounds, and the atomic mass unit gave masses of most of the elements as whole numbers. As whole numbers, okay? Why are we saying that whole numbers is important? Why are we saying that we need the masses in whole numbers? It is always very convenient to have the values in whole numbers. If I'm saying 3.75 is the mass of aluminium, just a random example, this is very inconvenient. But rather, if I say it is 4 or either 3, then it is very convenient, okay? Therefore, it is always the aim to get the values in whole numbers, okay? Fine. Moving on. In 1961, for a university accepted atomic mass unit, be mindful of the atomic mass unit here. Carbon 12 isotope, I've already discussed the meaning of isotope here. Carbon 12 isotope was chosen as the standard reference for measuring atomic masses. Carbon 12 atom was considered as the reference point for measuring atomic masses, okay? 1 atomic mass unit. Be mindful of this, bachcho. 1 atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. Just now I wrote this. 1/12 the mass of carbon-12 atom, right? This is what? This is 1 atomic mass unit. 1 atomic mass unit, right?
Yes, ma'am.
Yes,
Yes.
ma'am.
The relative atomic masses of all elements. Why relative? I've already told you, because we are measuring the masses of all other elements in relation to this standard unit, okay? In relation to this reference point, have been found with respect to one atom of carbon-12. Clear? Is this point clear?
Yes, ma'am.
Yes.
Yes, ma'am.
So now moving on to the next point. Bacho, I would want you to go through this paragraph very quickly by yourself, because this is any other example just used to tell the meaning of atomic mass unit. If you can go through this by yourself, I'm waiting, please. So then it will be clear whether the concept has been understood or not. Okay, please go through it. Ali, Bacho, please. Acha, you are using the screen? Fine,
Yes, ma'am.
fine.
Done, ma'am.
Done. That means
Yes.
understood, Bacho? The same
Yes.
concept, right? The same concept. There was no unit to measure the mass of the watermelon, okay? Or the fruits. What we did was, we took any random one watermelon, okay? We divided that into 12 pieces. And one piece out of those 12 pieces of any random watermelon that we took, we use that as the standard point. We use that as the standard point, right? Therefore, if I'm saying give me 1 unit of this fruit, 1 unit of this fruit, therefore, whatever equals to this mass, okay, whatever equals to the mass of this one part will be the unit here, okay? Clear? Relative fruit mass unit. Simple. Faraz, bachcho, clear? Ali, clear? Abdullah, clear?
Yes, ma'am.
Yes, ma'am.
Fine. Abdullah, tell me this very honestly, is it clear to you?
Yes, ma'am.
See, this is the in simple words, simple foundation of chemistry. If this is not clear, no concept would be clear in actual chemistry. Every property is either based on the mass number or the atomic mass, okay? That's it. And this is the atomic mass that we are dealing with. Fine. So, similarly, the relative atomic masses of the atom of an element, is this phrase clear? Atom of an element. Why are we saying atom of the element? We have discussed this in the last classes. I'm not going to explain this. As the average mass of the atom as compared to the 1/12 the mass of one carbon-12 atom. See, why are we saying comparing? Because we are saying 8 times, 2 times of this mass, 2 times of this mass, right? 3 times of this mass. What is this? Simple comparison, right? Ali, you got 40 marks, okay? I got 20 marks. What will I say? Your marks is 2 times my marks, right? Your marks is 2 times my marks. Simple comparison. The mass of oxygen atom is 16 times the mass of 1/12 the mass of carbon-12 atom, right? The mass of oxygen atom is 16 times of that one part of the 12 parts of the carbon-12 atom. Simple.
Yes,
Simple
ma'am.
comparison.
Simple.
Therefore, relative atomic mass. Clear, bacho? So quickly go through the values of the atomic masses that we have for different elements, bacho. Hydrogen is 1. What does it mean? What does it mean? The mass of hydrogen atom is 1. What does it mean? Good.
That means
Fine.
every mass has like one unit mass of unit of mass.
Yes, it has 1 unit of mass. But if I ask you to tell me what do we mean by 1 unit, what will you say?
It is equal to 1/12 of the C12 atom.
Excellent. Basically, when we took this one part of the 12 parts of the carbon-12 atom, right? The mass of this one part out of the 12 parts of the carbon-12 atom is equal to the mass of the hydrogen atom. Simple, right? Because this is what we're taking as the unit. Yes, bacho. This is what we're taking as the unit. Clear? Ali, is that clear?
Yes, ma'am.
Fine. Carbon, what's the mass of? See, this is important here. Look here. Focus here. I said I took carbon-12 atom, right? I divided this into 12 pieces. That one piece out of the 12 pieces that we got the mass of this one piece, I took it as the standard point, right? Or the unit, right? If I'm saying I'm measuring the mass of the carbon atom, definitely it will have 12 pieces, 12 times the mass of this mass, right? Why? Because we have 12 pieces here. Are you getting this? The mass of carbon atom will be what? 12 units,
12 units.
right? Why, Ramesh, Bachi, why are we getting the mass of carbon as 12 units? Can you explain that to me?
Because 12 parts, right? So if you add them all, you get 2 units.
Okay, Ali, why are we getting the mass of carbon as 12?
Because every like one one
Relax.
all 12 pieces are equal, and like everything every has
Exactly.
same value.
So definitely, if this is one piece, okay, see, if this is one piece, that's the standard part, right? That is my unit. If I take this as 12 times, definitely the mass will be 12 units. And we know that in this carbon atom, we have 12 pieces of this part, right? Therefore, the mass will be 12 units. Clear? Therefore, the mass will be 12 units. Umema, is it clear to you? Why are we getting it as 12 units for carbon?
Yes, ma'am.
Yes, ma'am.
Umema, Abdullah,
Yes, ma'am.
fine. I think our younger siblings are also enjoying chemistry, huh? No worries, fine. Nitrogen, 14 units. Therefore, the mass of one nitrogen atom is 14 times the mass of that one part of the carbon 12 atom, right? Simple. Sodium, 23, magnesium, 24, sulfur, 32. You should know the masses of all of these elements. You should know the masses of all of these elements. Very important. Calcium, 40. Chlorine, 35.5. Why 35.5? Because this has been taken as the average of two different chlorine isotopes. Okay. Therefore, this has been taken as the average. Therefore, we are getting the decimal form. Clear?
Can you explain isotopes, because I think I was absent that time. I have no
Yes,
idea
you were
what is
absent, and I explained that in detail then. After the class.
that. Okay.
Okay. After that. Fine. But any problem in the atomic masses? Any problem in the atomic masses? From the historical developments to as of what we use for the standard unit right now. Okay. Everything has been clear. The unit now is U. Please know that earlier it could have been AMU. Okay. I mean, it was AMU, but now it is U. Okay. And what's the full form for U? Unified mass. What's the full form for U? Unified mass. Clear? I've already discussed how do atoms exist, what is a molecule. Now I'm coming on to the next topic, that is molecular mass. First, I would want to discuss the molecular masses. Okay. Molecular mass. What is atomic mass? The mass of the
One atom,
atom.
Atom.
What is molecular mass? The mass of the
Molecule.
molecule. Simple. Let's say this is H2. I hope all of you will agree with this that this is a molecule. Please say yes.
Yes,
So
ma'am.
it's a molecule.
Yes, a molecule. Okay. Now, if it's a molecule, it will have some mass. What is it that is making this molecule? There are different atoms of different elements that is making this molecule, right? Atoms of different elements are making this molecule. Certain number of the atoms of different elements are making this molecule. 2 hydrogen atoms, right? 2 hydrogen atoms plus
One
oxygen
oxygen.
atom. If I ask you the mass of this molecule, I think you will clearly say that the masses of all the atoms of all the different elements present in this molecule, the sum of that will give you the mass of this, right? Will give you the mass of this. Calculate the mass of one molecule of water very quickly. What's the molecular mass of water?
18.
18, right? That has been discussed multiple times, but try it. See, the mass of one hydrogen atom is 1. And how many atoms here?
2
Right?
atoms.
2. Be mindful of the units. Very careful of the units. What is the mass of one oxygen atom? 16 units.
16.
18U is the mass of one molecule of water. One molecule. Had there been 2 molecules, the number would have doubled. The value would have doubled, yes?
Yes,
And I've
ma'am.
already discussed how many atoms are present in different number of molecules. How many elements are present. Yes, Ramita and Umayma, you were present in the class. That has been
Yes, ma'am.
discussed. Fine. Fine. I'm giving you the examples here. Calculate the mass of this molecule of carbon monoxide. Carbon monoxide. Quickly.
28.
28. Fine.
U.
We'll see how. U. Good. The mass of carbon atom, right? Mass of carbon atom plus the mass of oxygen atom. So into 1 and into 1, because both of them have 1 atoms here, right? Both of the elements have 1 atom here each. 12U plus 16U gives us 28U, right? Quickly calculate the mass of sulfuric acid. Abdullah Bachi, are you getting this?
Yes, ma'am.
Understanding this? You will
What's
tell me
the
the
atomic
mass of,
mass for sulfuric acid, sulfur?
have the NCRT, Bacho, have the NCRT.
Okay.
32. It's 32 although. Okay. The atomic mass for sulfur is 32.
Ma'am, for which molecule?
H2SO4, sulfuric acid.
H2SO4.
Yes. H2SO4. No one will answer. I will ask a particular student and then only they'll answer, okay? But do it from your side. I've just written the formula here, that's it.
Done, ma'am.
Fine. Anyone
Done.
else who has done that? Fine. Yes, Abdullah Bacha done.
Yes, ma'am.
Umayma, Ramesh done.
Oh.
Fine. Abdullah. Sorry, yes, Abdullah.
Yes.
Just tell me how many elements are present in this compound. Is this a compound? First of all, is this a compound?
Yes, ma'am.
Yes, it's a compound. How many elements are present in this compound? Ali, how many elements are present in this compound?
2 elements.
2 elements. What are they? Name them.
Hydrogen and sulfur.
Hydrogen and sulfur. Fine. Faraz, bache, how many? Although I have not taught you yet. Fine, no worries. Umayma, how many elements are present in this compound? Faraz, will discuss this tomorrow, inshallah. Okay, in your class. How many elements are present in this compound, Umayma?
2.
2. Ramesh.
Ma'am,
Ma'am.
3. Ma'am,
Yes,
I think
Ramesh,
it's
bache. Okay, Umayma, I get your point. 3. Well, name them. Name them. Umayma, name them. Hydrogen, sulfur, and
Oxygen.
Ali, bache, did you not see this over here? Huh? Fine. So hydrogen, sulfur, and oxygen, these are the 3 elements which are present in this compound, in this molecule of this compound, right? We have 1 molecule of this compound here. First of all, know this, 1 molecule of this compound here. Umayma, how many atoms of the hydrogen element?
2.
2 atoms. Ali, how many atoms of sulfur element? Abdullah, how many atoms of oxygen
30.
element?
Yes, ma'am.
Bache, how many atoms of the oxygen element present here in this
4.
1 molecule? 4. Ali, how many atoms of sulfur, bache?
32. No, 1 atom.
How-
1 atom. Sorry, 1 atom.
That has the 32 compound. Yes, 1 atom. Okay, that's the atomic mass. Fine. Now we know the number of atoms present in this molecule. Now can you calculate the atomic mass? Sorry, the molecular mass, right? Now can you all calculate the molecular mass?
Yes,
Do
Yeah.
that. What's the formula here? 2 into 1. Why? Because 1 is the atomic mass of hydrogen atom. And 2 times of that plus 1 into 32, right?
yes,
Plus
ma'am.
4 into 16.
16.
U, and U. We'll get that as 2U plus 32U plus
64U.
64.
98U.
98U, excellent. The mass of one molecule of sulfuric acid is 98U. Clear?
So I got same.
Got the same? Fine. Abdullah Bache, did you understood this?
Yes, ma'am.
Have you understood this? Fine. Faraz?
Yes, ma'am. Yes.
Fine. Umama Bache, done?
Yes, ma'am.
Fine. Next question. Should I give you one more question or should we move on to the next topic? Whatever
No,
is your
one.
call.
One more question.
Yes,
One
ma'am.
more
We'll do one more question.
One more question? Fine. Magnesium nitrate, quickly. I hope you would have understood the approach. First, know how many elements are present, then know the number of atoms of each element, and then calculate the mass. Okay, that will be very easy for you, very convenient.
Done, ma'am.
Done, fine. Wait, we'll discuss it.
Done, ma'am.
Faraz and Umama, Abdullah, done, bachcho?
Yes, ma'am.
Should I discuss it? Fine. Excellent. How many elements? Quickly, how many elements? First point. How many elements?
Three.
Three. Namely magnesium, nitrogen, and oxygen. How many atoms of magnesium?
One.
How many atoms of nitrogen?
One.
One.
How many atoms of oxygen?
Three.
Three.
So 1 into 24, right? 24U. 1 into 14U, right? And 1 into, sorry, 3 into 16U, right? We'll get the answer. That's it. Okay. What's the total?
86
What-
86U.
What's the total here?
86U.
24U. Okay.
88.
48. Get us?
86 U, right?
86.
You will do the calculation. Okay. The approach has been understood. Fine. Now
Ma'am.
see, there's one more term called as formula unit mass. Okay. Formula unit mass is nothing but relative molecular mass. Acha, for next point here, the molecular mass that we have calculated is also called as the relative molecular mass because that is been calculated from using the relative atomic masses. Okay. So simple point. This is also relative molecular mass. Okay. But it is specific relative molecular mass as in when the compound or the molecule that we are having is made from ions. Made from ions. Example, NaCl is a compound, is a molecule here, okay? It's made from ions. Na plus bonded to Cl minus, yes? Now the molecular mass of this compound will be called as the formula unit mass. Clear? Example, sodium hydroxide, okay? Just an example, okay? Example, magnesium nitrite, okay? Ions, okay? Magnesium nitrite. Ions, okay? So basically, whatever molecule we are getting from the combination of the ions, the relative molecular mass of that compound will be called as the
Formula unit mass.
formula unit mass. Clear? So that is clear. That should be clear.
Yeah.
Yes, ma'am.
Now, once we have understood the atomic masses and the molecular masses, okay, we can calculate the ratio. We can calculate the ratio of the masses of different elements in a particular compound. Example, what we were doing in calculating the ratio in water, we were saying 1:8. How did we get this? We got this by using the masses, right? The mass of hydrogen here in water is 2. is to the mass of oxygen present in this one molecule of water, that is 2:16. We know this, right? U and U. We get the ratio as 1:8, right? So
Yes,
this
ma'am.
is also clear. Can you calculate the mass, the ratio for sodium chloride? Can you calculate the ratio for sodium chloride? The ratio of the different elements for sodium chloride, बच्चों. That is very
23 is to
simple.
0.5.
Yes, yes, excellent. 23 is to 35.5. Yes, simple point. Okay. Fine. So now coming on to the last point here, molecular mass. See, बच्चों, the concept can be extended to calculate molecular mass is same. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. Fine. Atomic mass unit. What will be the unit here? Again, U. I've already discussed that. Okay. So what we have calculated? Calculate for HNO3, nitric acid. Quickly calculate the mass for HNO3. HNO3. Calculate the molecular mass.
Is it 61U?
Let's see, is it 61U or not? Okay. How many atoms, how many elements present here in HNO3? How many elements?
3.
3. How many atoms in total?
5.
5. So the molecular mass of HNO3 is equal to the atomic mass of H plus the atomic mass of N plus 3 into the atomic mass of oxygen. We get as 63U. Okay. Excellent. Be mindful of the units. That's the most important point here. Fine. Let's quickly see formula unit. The formula unit mass of a substance is the sum of the atomic masses of all the atoms in a formula unit of a compound. What is the formula unit? Made by calculate the same manner as we calculate the molecular mass. The only difference is that we use the word formula unit for those substances whose constituent particles are ions. Discussed, okay? NaCl, NaCl and things like that, okay? Whatever you have. For calcium chloride is a formula unit mass. Quickly calculate it. See, I know I've already have it on the screen, but please try to be honest. Done. You will get as 111 U. Okay. Now see.
How
look
many
here.
atoms of chlorine are present?
But say 2,
Two?
CaCl2, yes. CaCl2, okay. Calcium chloride. See, now look here. We have discussed almost all the topics of this chapter. One last topic is left, that is how to get the chemical formula. Okay. One last topic is left, that is how to get the chemical formula. Inshallah, in the next class, we'll be covering that up. Again, hopefully we'll be finishing that also. Okay. But before that,
Ma'am,
before starting that topic, listen, Faraz, can you just mute yourself? Yeah, thank you. Before starting that topic, my suggestion, advice, and request would be, please go through the topic of how do atoms exist. The topic where I discussed about the atoms, molecules, elements, and compounds. How do we get to know the number of atoms in a molecule? How do we get to know the number of molecules of a certain compound present? How do we get to know the number of atoms present in more than one molecule of a particular compound? Okay, all of that has been discussed. And before starting that topic, basically to understand that topic, those concepts should be clear. Okay, and those of you who did not attend those class, please go see the recording of that lecture. It will be present on the, just ask for the team, okay, and go through that, because in the next class, I will not be revising the basics then. Here, I will be directly starting with the concept of chemical formulas. Okay with all of you?
yes,
Okay,
ma'am.
ma'am.
Fine. Someone has sent me something in the chat. Yes, question paper. Umaima, I have class in my next class in next 2 minutes. I'll be discussing that in the next class then, inshallah. Sorry for the delay. Okay. If you want to discuss anything specifically, you can discuss with me just after this. Okay, I'll take 2 to 3 minutes off. All of you may leave, please, Umaima, you please stay.